Hello friends, welcome to SahuStudies. In this video, I am going to discuss about difference between aggregate by key and combine by key in Scala. So if you talk about aggregate by key and combine by key, both are the transformation of operation used to perform aggregation on the value which are associated with each key in the pair IDD. So both aggregate by key and combine by key both will take pair RDD as an input and the data must be in the form of key and value. And what they will going to do, they will going to perform aggregation on the values which are associated in each key. I am talking about in each key. All the aggregation function will going to execute on per key label. They are slightly different in service the purpose. They offer different level of control on the aggregation process. So one of the main difference between aggregate by key and combine by key is that it provides different kind of a control over the aggregation process, which generally going to applied on all the values which are associated with each key in the pair RDD. So let's discuss more about individually what is aggregate by key and what is combined by key, and again we will discuss some of the differences, right? So let's talk about the aggregate by key first. So aggregate by key is a fundamental transformation function, right? It is one of the transformation function. It is an optimized and broader transformation. So this is very important. What do I mean by optimize? I means optimize is that the shuffling process is happening at the last stage of the transformation, and most of the shuffling process happened in per partition label, and one partition you can say is equivalent to the one key, right? And this is a border transformation. That means shuffling of data will going to take place at the process of the transformation. But the main advantage of aggregate by key, as I told you, that shuffling of the data will going to take place at the last stage, and it also reduces the data. So whenever this aggregation function we are going to perform, it will first aggregate all the element in a partition at the partition label. Then the data will become very small, and again it will aggregate all the result of each partition to get the final result. So less data will be shuffled, less data will be stored in the memory, then the performance will be optimized. It is helpful if there is a requirement of the aggregation and the input and output are different. So this is one of the key benefit of using aggregate by key. If there is a requirement that I am giving an input in one form and I want the RDD in the different format, aggregate by key will going to help in this scenario. It supports aggregation such as mean, max, average, etc. sum. So these are the very basic aggregation functions. So all the basic aggregation function supported by aggregate by key. So it aggregates the value of each key by combining function and a neutral zero value and return different type of values of that key. So what does it mean? It means that first it perform the combine function at the partition label, and first it will going to initialize the accumulator we can say with the help of a zero value. So whenever the combining function happening over a partition with the help of aggregate by key will initialize the accumulator with the help of a zero value. It is useful when you need to perform both per key aggregation and change the value type during the aggregation process. It takes two functions as an argument, sequence and combine. As I told you that it performs the aggregation on the per key label, and whenever we are going to use aggregate by key, it takes two argument, and that is a kind of a function. One is the sequence function and one is the combine function. The aggregate by key operation allow you aggregate the value for each key while also maintaining the aggregated value type different from the original value. So this is the same thing which I have just discussed, that whenever we want to have the result which is a different type of the input, so with the help of aggregate operation we can able to achieve that. So this is a pictorial representation of the aggregate by key. Let's understand it. Okay. So this is the data which is present in the different executor, right? So, or we can say different partition. So this sequence function, I told you here now there's a two function. It generally takes as a parameter. One is sequence function and one is combined function. So this is, I'm talking about the sequence function. What the sequence function generally does, it creates the value like this. This is the IT is a key, and it will going to create a set which contains all the value which is associated with this IT. So here we can see there's a two value for the IT. That's why IT is the key, and these are the two values which are in the present in the form of set. Same for the management there's a two value. One is management key has a two value in this partition, or we can say in this executor. Same for finance, same for the operation. In here we can see this sequence operation. It is happening here, right? And it is combining the key and its value. Same for here, it is combining the key and its value. So sequence operation, what it generally does, it combines the key and its value and just reduce the data. So suppose here the data is in 10 MB. If the data is very huge, when the sequence operation will perform and the data will going to combine with key and its value in one row, maybe data will going to reduce to 2 MB. That's why this sequence operation plays a very important role. When the sequence operation happen, then what, this merge value from the different partition is happening. This is the same thing. Second function is the combine function. So what the combine function is generally does, it's going to combine the result of each partition, and it merge the value key and its subsequent value. So here the key is IT. So these two value, one is coming from this partition or this executor. These two values coming from this partition, and these two values are coming from this partition. Same for management, same for marketing, same is finance, and same is operation. We can say here the data is also getting reduced. Here the data is also getting to reduce, and here the data is also getting reduced. And here this is the merge value from the different partition. It will going to take a shuffling operation. In shuffling operation, data will be going to shuffle between different executor. So we can see that the data from this executor, and from this executor, it is coming to this executor. Since the data is very small, because with the help of a sequence operation, we have reduced the data. And when the shuffling process will happen, shuffling process happen in the memory, data will be less. It will going to accommodate in the memory, and the shuffling process will become very fast. So let's talk about combine by key. Okay, combine by key is a transformation function, and it's perform transformation operation on the pair IDD. Right. So it's also perform the data, or it also require the data in the pair pair RDD, and it also performs the transformation on the pair RDD. Combined by key is also transformation, also a wider transformation function, means that shuffling of the data across different executor may be possible. It requires shuffle operation at the last stage. As I told you, this combined by key is also going to do a shuffling operation. But one good thing about aggregate by key as well as shuffle by key is that the shuffling operation will going to take place at the last stage of the transformation. It is a very generic function to combine the element in each key using the custom set of aggregation function. So this is very important, right? This combined by key is a very generic function, right? And which is used to combine the value of each key using custom set of aggregate function. So here, what is the difference? We can write a custom aggregation function. One of the main objective of the combined by key transformation is that it transforms the RDD which is present in the key and value pair to RDD key and C will result any type of aggregation. So this is the key, this is the value. It will going to take as an input in the form of RDD, and when it will going to give the result, it will give the RDD which is the key and the value. Key would be whatever the unique key which is present in the RDD, and this C will be it is a result type of aggregation which has been performed over the values of a key with the help of a combined by key. If there is a requirement to perform a custom aggregation on the values of pair RDD while providing find gain control over the aggregation process. So whenever there is a requirement that we have a data set in the form of key and value, and we want to perform certain kind of a custom aggregation. So with the help of a combined by key, we can able to achieve it. So how we can able to perform the custom aggregation function? So generally we write three functions whenever we are going to use combined by key, and in those three functions we can write our custom aggregation logic. So one is the initial value. What initial value will going to do in the sequence operation? What sequence initial value will going to do? It will initialize the accumulator with 0 for each and every partition. Sorry. This combination function for the value within the partition. The second function, what it will going to do? It will combine all the value within the partition. And this third function, what it will going to do? This merge function to combine result across the different partition. So all the combination function on the values which is happen in each and every partition in the second step. Third step will going to take all the result of different partition and combine them to form a single result. Let's discuss about the combined by key function. So the mode of operation of combined by key function is same as reduced by key. Okay, so suppose this is the three partitions which is present in these three different executors. So these are the value in the key and pair. So this is reducing or doing the aggregation. Suppose here we are doing the sum aggregation. So this is doing the aggregation at the first partition level. So here it has done the aggregation. It has one value, one record. That's why the aggregated sum is like this only. This is the second partition. It has two value of A key and two value of B key. Here it has been reduces or has been done this aggregate function sum, and it reduces like this. A is 2 and B is 2. Since this is the sum aggregation, so it is summing up the value of the each key. This A is the key. There are two records. Each record has value 1. That's why it is summing up as 2. Same goes for B. Right. This is the third partition. Here the key A has are 3 numbers. Key B are 3 number. Now in the same partition, it has done the aggregation function. Here is the sum aggregation function, and it is doing the result like this. A is equal to 3, B is equal to 3. Now, when it reduces to a single value per key, it will going to shuffle the data at the last stage and creating two partition. So this one is coming from this partition. This A2 is coming from the result of aggregated result of this partition. A3 is coming the aggregated result of this partition. Here also this B1 is coming from the aggregated result of this partition. B2 is coming from the aggregated result of this partition, and B3 is coming from the aggregated result of this partition. So we can see here the shuffling is happening between different executor, but shuffling is happening at the last stage of the transformation. When the data is present in created a different partition for each and every key, then again the data is reducing. Means reducing means the data, the aggregate sub aggregate function is applying in this key and value pair, and one value it is returning, that is A is equal to 6. A is the key, 6 is the total sum of the values which is present as a value in each and every key which is present here. Same for B. So we have seen here the combined by key is very similar to reduced by key. Okay, and the aggregation, any kind of aggregation, first it is happening at the partition level, and then the shuffling is happening at the very last stage. Now let's discuss about what is the differences. So let's talk about aggregate by key. It allows custom aggregation function. We have discussed about that if you want to do any kind of a custom aggregation apart from sum, mean, max, you can able to do with aggregate by key. It maintains aggregated value of the different types. So if the output would be different, then we should use aggregate by key. Whatever the input, output would be different if there is a requirement. Then use aggregate by key. It does partial aggregation before shuffling and also reduces the data before shuffling. And we have discussed that the aggregate by key does the aggregation on the per partition level and reduces the data. When the data will be reduced, the shuffling operation become very fast, because that small data will be able to adjust in the memory, and it will shuffle fast across different executor over the network. It provides more flexibility in defining the custom aggregation function. So if we want to do a custom aggregation function, then we can write a custom logic, right? So this is one of the major advantage of using aggregate by key. It controls the memory and performance and help and with the help of an aggregation function. So how the memory and performance will be optimized? I have told you that aggregation function first applying in per partition, data will be reduced drastically, and again the shuffling process is happening, which will going to merge the resultant of the aggregate operation which had happened on each partition at the last stage. So data will reduce drastically. Data will be able to store in the memory, and the data will be shuffled across different executor over network very fast. Let's talk about the combined by key. It allows more flexibility in the custom logic, custom aggregation logic. So it is giving the more flexibility if you want to write any custom aggregation logic which you want to perform with the help of combined by key. It allows a specify function for creating initial value, merge value across different partitions. So as I mentioned that whenever we are going to use combined by key, it is taking three parameter. One is initial value. Initial value is nothing but it will going to add initial values most of the time 0. Okay, if you're talking about the sum aggregation or mean or max aggregation, so it will going to initialize the accumulator in each and every partition with 0. And this merging value, it will going to do merge the values of per key in each and every partition. And this merge value across the partition, what does it means? The resultant of this merging values in different partition, it will going to combine those resultant value from each and every partition to give a single value. It offers more control over memory usage and performance by defining appropriate aggregate function. As I told you that uh, shuffling is happening in combined by key also, but shuffling is happening at the last stage of the transformation. And first, the data will be reduced drastically by with the help of appropriate aggregate function, and the aggregate function is happening at first at the individual partition label, and after that it is shuffle the data and combine the data same pair uh, with the same value in a different executor or in a different partition. It requires more effort in implementation. This is one of the major disadvantages, because whenever you are going to use combined by key, we need to write three functions. So three function, the implementation will going to take time. That's why I have written here that it requires more effort in implementation. So these are the some of the differences between aggregate by key and the combined by key. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.